Welcome everyone. My name is Lars Schneier and I'm the tech lead for GitHub Solutions at Autodesk. And today I want to talk about how we use Git at scale. Yeah, and it works. So why is adopting Git a challenge for us? Well, Autodesk has been around for more than 20 years and we have more than 4,000 engineers working on hundreds of projects. And some of these projects you probably know, like AutoCAD, Inventor, or Revit. And for historical reasons, these projects are in all kinds of different version control systems. So we used to have plenty of Perforce servers, Subversion servers, Mercurial servers, TFS servers, Git servers, pretty much anything you could think of. And we realized, well, that is bad for collaboration. And for that reason, we decided last year to move all our development to Git on top of GitHub Enterprise. So what are my topics today? First, I want to talk about how we ease the Git onboarding for our engineers. Keep in mind, most of our engineers, they haven't used Git before, at least not professionally. So we want to make it as smooth as possible for them to onboard on Git. And the second part of the talk is I want to talk about our Git usage recommendations. As you all know, Git is a pretty complicated tool, and you can use it in all kinds of different ways. And we want to make sure that our engineers use it in the best way possible, so that they are productive right from the start. And last but not least, I want to show you how we monitor our Git usage. This is important because with the monitoring, we can identify inefficiencies early on, and then we can talk to the teams and to the developers and help them to use Git in a better way. So let's get started with the onboarding. Pretty easy. The first thing that you need to decide at a company is what kind of protocol do you recommend to your engineers when they use Git? The Git protocol is no real option because it requires authentication. The SSH protocol is great, but the initial setup, especially on Windows, is kind of tricky. And for that reason, we recommend the HTTPS protocol, which works great on all platforms. So our engineers, they started to use the HTTPS protocol, and pretty quickly they asked us, why do I have to type my password all the time? So we got plenty of reports of tickets asking this question. And all of you know, the answer is pretty easy. You just need to set up your credential helper. And then you don't have this problem anymore. Another support ticket that we got quite a couple of times is, why are my commits not associated to me? And again, for an experienced Git user, that is easy to solve. You just need to set up your Git config properly. And, well, we got these really tiny, trivial problems all day long. And we realized, well, trivial tasks performed by more than 4,000 people, they generate actually many support tickets. And, well, we thought, okay, what can we do to make this better? And we came up with Enterprise Config for Git. And what is this? That is a painless Git setup with an easy way to share Git configs and scripts within a company. So how does it work? Well, Enterprise Config is built around a setup command. And in order to make sure our engineers really get that this setup command sets up their environment for Autodesk, we call this setup command git adsk. And when you run that, a couple of things happen. So first, we self-update, so that we ensure that the engineer has the latest version of our config. Second, we check the local Git version that is installed. And this is important, as you probably have heard of this security vulnerability in all Git versions prior to 2.8. So for these kind of things, it's important because we can actually tell the engineer, well, your machine is outdated, do something about that. And we also check Git LFS. We check it if it is installed. So if it's not installed, then we install it. And if it is installed, then we check that the right version is installed. This is really important because we have a lot of repositories that use LFS, and we want our engineers to have a seamless experience when they interact with them. And the third thing that it does, it sets up your local user properly. And this is really easy to do in an automatic fashion because we use GitHub Enterprise, and our GitHub Enterprise instance already knows your name and your email address. So we can just use the GitHub API to fetch this information and run the proper git config calls. And last but not least, we set up the credential helper for the respective machine. And the credential helper is actually a pretty interesting topic. And I wonder, if you use HTTPS, the HTTPS protocol on github.com, then I want to encourage you to try this little bash snippet in your shell. What you will realize when you run it is, well, you can see your HTTPS credentials in plain text. And this is bad. But it is especially bad in an enterprise environment, because in an enterprise environment, these credentials are used usually for pretty much anything in your enterprise environment. You use it for email, for HR records, for, yeah, anything. And so this is especially bad in an enterprise environment. Fortunately, GitHub already knows about this problem, and they came up with a really good solution. And this solution are private access tokens. And what our enterprise config tool does is it will issue a new token for you, for your machine, and set up your credential helper with this token. So your domain password is kind of secure. These 4 things are rather general, and they could be interesting to other companies as well. But we do some additional stuff on top. So for instance, our engineers, they have to sign a source code agreement and have to renew that, I think, every 6 months or so. And these kind of things we check in our setup step as well. So if they have to renew it, we can give them like clear instructions what they need to do. And yeah, again, we reduce the number of support tickets, which is our main task here. So how does Git Enterprise Kit actually work? In essence, it is only a Git config. And it's a Git config that is yeah, basically distributed to the entire company. And in this Git config, we add an alias that we call the ADSK, and this alias calls a script, the setup script, which does all the things. And this company Git config is then included with the Git config include mechanism into the engineer's global Git config. So why do we do it that way? Well, first, this works cross-platform. So it works on Windows, Mac, and Linux. That's important for us because we use all these platforms. And second, it works out of the box wherever Git works in any shell. So you don't need to set up some path or something that is just not necessary. It works wherever Git works. So that's great. And it's also very easy to install it. So this is what we tell our engineers. They need to clone our enterprise configuration repository, and then they need to set up this this include path for their Git config, and that's it. And then it just works. This works really good on Mac and on Linux because Git is usually already installed. On Windows, that is not the case. And for that reason, we made a custom version of the Git for Windows installer, which basically does this automatically. And so our Windows setup is really, really smooth. And today, we made this enterprise config for Git actually open source. And yeah, you can go to github.com/autodesk/enterprise config for Git, and you can see how we implemented it, and maybe you can, it's even useful for you. You can fork it and then adjust it to your own needs. All right, and now I want to come to the second part of the presentation. That is, what are the usage recommendations for Git that we give our engineers? So the first one is pretty obvious to probably most of you. It's create branches. Why do we need to tell this to our engineers? Well, as I said earlier, our engineers come from many different version control systems, and most of them don't support easy branch creation. So that is something that an engineer needs to learn, that creating branches in Git is actually pretty easy and fun. The second recommendation is create many commits and push often to your private branches. That is again, yeah, that is something really important because your machine might die or your laptop might get stolen and then your work is gone. And if you do this kind of thing, like pushing often, then your work is always secure. And that's, of course, important for a company. The third recommendation is rather controversial, but we recommend merge instead of rebase. Yeah, at least until the engineer really knows what rebase actually is and does. We realize that this just helps a lot with to avoid like trouble with Git repositories. So because with rebase, one engineer can actually screw the experience for the entire team, which is not good. GitHub is actually helping in that area a lot too with a recently introduced feature that is the protected branches feature. And I really recommend you to enable that for all your shared branches. Yeah, just because if people play around with rebase, then the other engineers are safe. The fourth recommendation is kind of connected to rebase, but we tell our engineers to avoid cherry picking if possible. And yeah, why do we do this? Well, cherry picking sounds very interesting to people that come from version control systems that are Delta-based, like Perforce. So, but when you cherry pick a change from one branch to another, then the change is equal, but the commit is not the same. And that's a very important thing, because when you cherry pick, then yeah, you have the same change multiple times in your Git repository, and this becomes yeah, this is bad for two reasons. First, when you look at the history, then that might be confusing because the same change is the same commit message is in there with different hashes. So what's going on? And more importantly, when you have a conflict in this particular change, then you need to resolve the conflict in every branch that you cherry pick the change to. So this really destroys your good merge experience in Git. And that's why, yeah, we don't recommend cherry picking for your default workflow. You can use it in an exceptional case, but not by default. Well, we recommend it not. The fifth recommendation is, again, rather obvious. Use git ignore. Git ignore is a very good mechanism to avoid bad things in your repository. So if you have a good ignore pattern, your people won't commit big temporary files that you then have to deal with. And we recommend always this very good service, gitignore.io. If you don't know it, check it out. It's great to generate perfect ignore patterns. Sixth, and this is a recommendation that really hurts us, or that is really complicated for us, that is avoid many files. If you have a Git repository that contains more than 100,000 files, then Git operations tend to get slow. And this is especially the case on Windows. Yeah, unfortunately, there's not too much you can do about it, besides using an SSD or something. The only real yeah, thing that you can do is split your code base. So we recommend our engineers to take out components of their big repositories of less than 100,000 files and put them somewhere separate. And one good way to componentize a repository is to use submodules. Submodules are kind of controversial because, yeah, I think you start only to like them when you really understand how they work, because otherwise they're just the UI is a little bit confusing at times. But for us, they work pretty well. Although, yeah, one word for advice here. So they only work really well if you use a lot of automation around them. And a couple of examples. What we do here is, for instance, we detect if a submodule was updated, and then we generate a pull request against the parent repository with the submodule update. And then an engineer sees the update and can just press merge to update the submodule. So this works great. And when we do this, then, or whenever you have updated the submodule on GitHub, you probably have seen the submodule update is just a change of a hash from one hash to another hash. And that really doesn't tell you anything. And that's actually quite confusing. And for that reason, we take these two hashes, the old hash and the new hash, and generate the GitHub diff URL of the submodule, and then add this as a comment automatically to the pull request. And this way, a reviewer can just click on this diff URL and then see what has actually changed in the submodule. And yeah, that works great. And one catch there is too, when people are not careful in with their commits, they might revert the submodule to an older version. And this is kind of stuff we detect there too, and then warn the reviewer about that. So yeah, again, automation helps a lot with submodules. When you use submodules, then we also recommend yeah, the following things. First, avoid nesting them. Consider a submodule. Consider 3 levels of submodules. If you make a tiny change on the 3rd level, you have 1 commit. Then you need to update the submodule pointer on the 2nd level. You have 2 commits, and you need to update the submodule pointer on the root level. It's the 3rd commit. So you make a tiny change, and you have 3 commits. That doesn't really scale, and it's not fun to use. So avoid nesting them. Only use 1 level of submodules. And another advice is avoid more than 25 submodules. We made this number up, but it's kind of the number that we've found works great. If you use more than 25 submodules, then Git really becomes slow. And the main reason is that the submodule system in Git is implemented in Bash, and this is not particularly fast on Windows. But Stefan Beller from Google is improving this right now, and hopefully we will see a lot of a good speed improvement there in the future. And last but not least, yeah, use Git LFS for large files. That's something we do, and that works really well. So now I want to look at 2 of these recommendations more in detail and show you how our enterprise config tool helps with these recommendations. So the first one is Git push. If you think about it, Git push is actually pretty scary in an enterprise environment. Consider the case of an engineer that's just started Git, and he's working on a secret company project, and he has a Git problem, and he goes to Stack Overflow and finds a solution and copy-pastes the solution, and for some reason he changes the remote to some public github.com URL. Well, and then he hits Git push. Well, the damage is done at this point, right? Not if you use our enterprise config. In this case, you would get a fatal error like that. Attention, do you really want to push to github.com? And in some cases, pushing to github.com is actually legitimate. For instance, if you make an open source contribution or something. So we also let the engineer know, okay, if you know what you're doing, you can run this command, and then the push will actually go through. So unfortunately, there is no such thing as push protection in Git right now. So what did we do? We had to be a little bit creative. So we used the URL rewrite mechanism of Git config to rewrite the github.com URL to this very long message, attention, something, something. And when we run git push, then Git will actually try to push to this very long message. And of course, this will fail because it's no real Git repository. But luckily, Git shows the message. And that's what we want, right? So this works great on the command line. And it works great on all the GUI tools that use Git under the hood. So like source3 or SmartGit. And yeah, that's our Git push protection. I think Git push protection would be a pretty good thing for Git, and for that reason I wrote a proposal for a Google Summer of Code and outreach project, and we have already a student looking into this. So maybe we have this feature in Git core pretty soon. The second thing I want to look at in more detail is how we use Git LFS. So Git in large files, well, that's a topic where you can read a lot about on the internet. And I would like to summarize the problems here a little bit, and that is files that change often and are large after compression are bad for Git. What do I mean by that? Well, if you have a 10 megabyte file that you just committed once and never touch again, that's no problem for your Git workflow, really. So even if it's a big binary file, no problem. On the other hand, if you have a 100 megabyte XML file that maybe you change often, that's no problem either, because XML usually compresses really good, and Git stores everything gzip compressed. So yeah, it's for that reason all this Git in large files it's not a really tangible topic, and in order to make it more tangible for our users and to give them a rule of thumb, we came up with this little formula to help them, and it is take the number of binaries that you have in your repository, multiply it with the average changes per year that you do to these binaries, multiply it with the average size in megabyte of these binaries, and then if the result is smaller than 100, well, you're good to go. You can just put everything in Git. Everything is fine. You won't get into trouble anytime soon. If it's bigger than 100, then you need to find another solution for these files. And another solution for these files is actually Git LFS. Actually, it is so popular at Autodesk that we have repositories with hundreds of files in LFS. And then we realized, well, a Git clone operation became really, really slow. The reason is in Git LFS is based on clean and smudge filters, and it processes these files sequentially and individually. So if you have a lot of files, then it takes a long time. So I contacted the Git LFS core developer, Rick Olsen, and he gave me good advice. He said, well, set this Git LFS skip smudge environment variable and run Git LFS pull afterwards, and it will speed up your cloning. This worked, but unfortunately only for macOS and Linux. And Windows, it was still slow. So I experimented around, and finally I found a solution that is actually 13 times faster. And I wrote a new command for using this enterprise config that we have, and I call this Git LFS Clone. And this is actually lightning fast, and it works really, really well for our engineers. And yeah, luckily, Steve Streeting from Atlassian, he picked up the idea and put this into Git LFS core, which is awesome, and it is apparently released with the next Git LFS version 1.2 in the near future. Okay, now the last part of the presentation, that is our Git usage monitoring. So when you want to look, when you want to find out what your users are actually doing with Git and with GitHub Enterprise, then you have two ways. One way is rather obvious. You can just enable log forwarding, and we forward our logs to Splunk. So what can you do there? Well, for instance, you can answer the question, who is cloning all the time? Why is this important? Well, people that come from version control systems like Perforce, they have this idea of, so when I want to make a clean build, I delete everything, and then I get everything from the server. Well, of course, in Git, that is quite a bad idea, because you, as you all know, you transfer your entire history. And that generates a lot of traffic that you don't want to. Some people are a little bit more knowledgeable, and they use the git clone --dep command to limit the amount of history that is transferred to the client. This is good, but this actually generates, or in order to process this, the GitHub server needs to create, or the Git server needs to create a special pack file for you, which requires quite some CPU cycles. So if everyone is doing that, that's not good for your Git server. And what we want to get, or we want to find people that are actually cloning all the time, and and then we look at the repositories that they are cloning, and we look at the size of these repositories, and then we generate a daily list. And these are actually the teams that we talk to, and we try to find solutions for them that work better within Git. And better within Git is, for instance, use git fetch and update this way your local repositories. And in many ways, this is possible. You just need to show the teams how it works. And this is good for them because their processes can get way faster because git fetch is faster than clone. And it's good for us because we save bandwidth. The second, maybe not so obvious usage monitoring way is the Git Enterprise backup. When you create a backup, then Git Enterprise will actually will store a MySQL database dump that you can import in your own MySQL database. And then you can write all kinds of queries to mine this data. And one of these queries is, for instance, who is actually using pull requests? We think pull requests are a great thing, and we want to make sure our engineers know about them and leverage them. And so we actually chart, okay, what teams are using pull requests, and how many pull requests do they actually use, how many pull requests do they merge, and so on. And this is very interesting to us because we have a big number of offices all around the world, and it's very hard to reach all of them. But with this kind of data mining, we can actually see what office is using pull requests and what office is not using pull requests. So then we can find them, and we can talk to them, and can show them maybe ways that they didn't know even exists. So this works pretty good for us. So to recap, what are the takeaways of this talk? So first of all, script your Git onboarding. Git is already hard enough to use, so make it as easy as possible for your engineers. Second, credential helpers are not really secure, so use tokens. That's important. Third, articulate your Git usage recommendations just to help your engineers to get started. And fourth, monitor your Git usage to help them to improve, to help your engineers to improve their ways to interact with Git. Okay, thank you.